Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 2. This is the first lesson, and this is Lesson 7, okay, which is actually the first lesson in Unit 2. There were 6 lessons in Unit 1, and they just continue counting up from there. So this is Unit 2, Lesson 7, which is the first lesson in Unit 2, and this is Session 1. So the learning targets for this section are to find the sum of a number and its opposite, use models to add positive and negative integers, and tell what a sum of integers means in a real-world situation. Okay, so let's dive in. And here's a first example. It's called Model It. And Neva plays a video game. On her first turn, she earns 3 points. So off to the side here, that's her first turn right there. On her second turn, let's do that in blue. That's her second there. She lost 3 points. The expression 3 plus -3 represents how many points she has after 2 turns. You can use integer chips to find the sum of 3 and -3. So these look like little round batteries. One's the positive side, the other's the negative, but they're calling these integer chips. Okay, so you can use these integer chips to find the sum of 3 and -3. A, the sum of any number and its opposite is 0. Okay, that's a real important concept. It may sound basic, but it's a real important concept in math. Okay, the sum of any number and its opposite is 0. Another term for opposites is called the additive inverse. Okay, inverse meaning opposite. You're adding the opposite. When you add the opposite, you get the additive identity, which is what it's called, and that is 0. So since the sum of 1 and -1 is 0, 1 and -1 form what is called a 0 pair. It says here to circle the 0 pairs in the model. Okay, so here's a 0 pair. A +1 and a -1 is 0. Here's another one, and here's another one. So they cancel each other out, if you will. So 1 minus 1 is 0. A +1 plus a -1 is 0. A +1 plus a -1 is 0 again. 0 plus 0 plus 0. Okay. How many points does Neva have after her second turn? So this is her first turn. The 3 positives in black and the 3 negatives in blue are her second term. So after her second turn, she receives 0 points. Okay, because we have 3 0 pair and nothing left over. So 3 plus a -3 is 0. Okay. Number 2. Neva starts the game over. The integer chips represent the number of points she has after her first turn. So this is her first turn. -1, -2, -3, -4, -5. So this equals -5. She then she earns 5 points on her second turn. 1, how many points does Neva have after her first turn? Well, that's what I already did. That's -5. So it's -5. Draw chips to show the points Neva earns on her second turn, then circle the 0 pairs. Okay, so there's 1, there's 2, there's 3, there's 4, and there's 5. So after her first turn, then she earns 5 points on her second turn. That's what they would look like. Okay, so draw chips to show, then circle the 0 pairs. Okay, so now I'm going to circle 1 0 pair. Here's a 0 pair, 0 pair, 0 pair, and this is a 0 pair. Nothing left over in either row. So how many points does Neva have after her second turn? Well, this equals +5. So we have 5 pairs of 0 pairs, and so that adds up to 0. So therefore, -5 plus 5 is also 0. Number 3, now we're going to use a number line. The number 5 and -5 are opposites. Explain why 5 and -5 have the same absolute value. So absolute value means distance from 0. Okay. So if I start at 0 and count, there's 1, there's 2, there's 3, there's 4, there's 5. So 5 is 5 units to the right of 0. And then if I count this way, there's 1, there's 2, 3, 4, and 5. So to explain why 5 and -5 have the same absolute value, what you would do is show it, you could show it this way. The absolute value of -5, meaning how far away is negative, excuse me, -5 from 0, and it is 5. And the absolute value of 5 is also 5. Why is that? They are both 5 units away from 0. Okay. Number 4. Use the number line to explain why 5 plus -5 equals 0. So what they've done here is they've taken this -5 direction that was over here. So let me pause the video. I want to show this. I want to animate this. Just give me 1 second. Okay, so this was from the last page, okay? And all I did was, the only thing that's missing is that black dot in the middle. Here's our 0. So -5 is going this way, 5 is going this way. Use the number line to explain why 5 and -5 equals 0. Okay, well, if I take this, all right, and move it to here, like, oh, let's put it down here. If I move it over to here, they're the same length, okay? So since they're the same length, they have the same distance from 0, if you will, and therefore that's why they are equal to 0. Going to the right 5, and then turning around and going back 5 puts you back at 0. That's another way to say it. So what we usually do here is when we start with a problem and we have 5, we go to the right 5, and then -5, we go back the other way 5, and that puts us at our final location of 0. Okay, that's the end of session 1. Okay, here's session 2, develop understanding of addition with negative integers. And it's the same learning targets as session 1. Find the sum of a number and its opposite. Use models to add positive and negative integers. And tell what sum of integers means in a real world situation. Okay, so here's a model it problem. Get my pen. On the first play, Angela's football team gains 5 yards from its starting position. So these are all worth 1. So there's 1, 2, 3, 4, 5. So that's a +5, positive 5. On the second play, the team loses 7 yards. So there's 1, 2, 3, 4, 5, 6, 7. So that's -7. So either they got tackled in the backfield or the quarterback got sacked, but they lost 7 points or 7 yards. Okay. To find where the team is relative to its starting position, which is called the line of scrimmage, you add 5 and then subtract 7. So A, you can use integer chips to model 5 plus a -7. Circle all the 0 pairs. So this adds up to 0. +1 plus a -1 is 0. +1 and a -1 is 0, and so on and so on. Once I do that, I have a remainder right here of -2. So what's the value of the remaining chips? -2. 5 plus a -7 is -2. After the second play, where is Angela's team relative to the starting position? They are back 2 yards. Okay, so if they started at the 20-yard line, they're now on the 18. If they're on their own end of the field, that is. Okay. Number 2, you can also use a number line to find 5 plus a negative 7. Draw and label arrows to show negative 7 added to 5. So what I'm going to do is I'm going to start with a point at 0. So I'm just going to draw a dot right here. I'll use green for positive. Okay, and it's 5. So that means I want to go to the right 5. That's what this means. Okay, start at 0. It's positive, so we go to the right. Now we're at 5. And then we're going to add negative 7. So then I'm going to get another number line. And go backwards 7. Okay. So let me put this right here. We're starting at negative 5 this time. And this is going backwards 5, 6, 7. Okay. So we started at 0. We went to the right 5. And then we went backwards 1, 2, 3, 4, 5, 6, 7. And we ended up at negative 2. What number do you end at? Negative 2. And therefore 5 plus a negative 7 equals negative 2. Okay. Number 3. The football team loses 5 yards from its starting position. 1, 2, 3, 4, 5. That's right here. Then loses another 2 yards. So that's plus another negative 2. So it's negative 5. These 5 here, first play. And then they lost 2 more yards on the next play. Why are there no 0 pairs of circles? They went backwards on both plays. So when you go backwards on both plays, both numbers were negative. So when you have negative numbers, you don't have any positives to put next to negatives to make our 0 pairs. So there's no 0 pairs here because there was no positive direction. What is the value of the chips? Well, negative 5 and then negative 2 more is negative 7. What does the sum mean in this situation? The team lost 7 yards on 2 plays. Okay. All right, next one, model it. Complete the model to find negative 5 plus a negative 2. So I'm going to get my arrow here, switch to arrow, switch to arrow, switch colors. Negative, I like to use red. Okay, so complete the model to find negative 5. So we start at 0. They gave us this model for negative 5. And then we're going to start at negative 5 and go left 2 more. I'm going to write negative 2 above this number line. So negative 5 plus a negative 2 is negative 7. Connect it. How is finding the sum of 2 plus a negative 3 using integer chips similar to find this sum 2 plus negative 3 using a number line? Okay, so how is using the integer chips and number lines similar? Well, let's go back to the number line where there were positives and negatives. So like this one here. So think of this as a positive 1. And so this direction is positive 1, but this direction was negative 1. So there is a 0 pair. This direction was +1, so this direction is -1, so therefore this is a 0 pair. This is +1, this weighs -1, there's another 0 pair. +1 this direction, -1 this direction, another 0 pair. +1, -1, another 0 pair, leaving us these two negatives, -2s by themselves. All these 0 pairs canceled, so our answer is what's left of 0. So that's the similarity of integer chips and number lines. How is it different? Well, the way it's different is we total them going on the positive direction, but then going backwards, we subtract all at the same time. Rather than adding and subtracting each one individually, you're adding up and going to the right. So in this situation, it'd be this here, right here. So let me erase all this. So what I'm saying is you're going all the way over to 5 in one motion, and then all the way back -7 in the next motion. So that'd be the same as here. We would go +2 and then left 3. So if I did that with a number line, I'll just draw one quickly. Okay, here's our 0. And so I start with my starting point, and here's 2. So that means go to the right 2. So my arrow would look like this. And then to go back 3, we would go 1, 2, and then one more, and end up at -1. Okay? So that's how they're different. We add all the values up together and then subtract them all. Okay, exit ticket. A football team loses 6 yards on its first play. It gains 8 yards on the next play. Use a model to find the sum of -6 plus 8. So I will do both. So let me go back. I'm going to cheat. I'm going to copy one of these. Oops. Okay. So if a football team loses 6 yards, you're going to look like, it's going to look like this. Okay, there's the model for losing 6 yards. And then I'm going to copy this. And I'm going to paste it here. And so this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8. These are negative. These are positive. Then I can take my pen and circle my 0 pairs. They cancel each other out. 1 and -1 is 0. And we're left with +2. So what does the sum mean in the situation? After 2 plays, the football team gained a total of 2 yards. Okay, that's the end of session 2. Okay, this is Unit 2, Lesson 7, Session 3. Refine. Ideas about addition with negative integers continued. We're still finding the sum of numbers and its opposites. Use models to add positive and negative integers. Tell what the sum of integers means in a real-world situation. So here we go. So now we're going to talk about temperatures and scales. So Celsius is a commonly used scale for measuring temperature in many countries. Other countries, such as the UK or United States, uses Fahrenheit to measure temperatures. What places have you been to or know about that use Celsius? Okay. Apply it. Number one, construct what two addition equations does the number line show? Describe a situation involving temperature that one of the equations could represent. Okay, so it says what two addition equations. So I'm going to highlight that. What two addition equations? So we're looking for two and we're adding, and equations mean there's an equals. So I'm going to look at this graph or this line. Okay. It's a y-axis or a number line vertical. And we're starting at 0. Okay. We always start at 0. Okay. So the first number I'm going to do is this -4. So I'm going to write -4 plus, okay, it's an addition equation. So it's -4, go down 4, plus, and then add 4. And that equals our endpoint, which is 0. So there's one addition equation. The other thing I could do is I could start at -4. Actually, I could start at adding 4. Actually, what two addition equations does the number line show? Well, it shows -4 plus 4. Okay. Describe a situation involving temperature that one of the equations could represent. Okay, so after some thought, I looked at I couldn't come up with another equation for this setup, but I looked in the book and the book said 4 plus a -4 equals 0. Okay, they're saying that could also be this number line, but I am going to flat out disagree because 4 plus a -4 equals 0 would mean we start at 0 and go up 4 this way, then turn and come back down this way and get back to 0, being on the other side. So I am going to totally disagree with the authors of this book with that being an option for this model. Okay, so there's only one addition equation that this represents. But then it says, describe a situation involving temperature that one of the equations could represent. So you could say, well, when I got up in the morning, it was 0 degrees. Okay. And by 12 noon, the temperature dropped to, okay, 0 degrees at 8 a.m. Temperature dropped 4 degrees by noon. And then the temperature rose 4 degrees by 4 p.m. Just say, I just threw in some times there. So you could just say, the temperature started at 0 degrees. It got 4 degrees colder, but then it got 4 degrees warmer. And by the end of the day, it was 0 again. Number 2. All right, number 2. Cheryl says that when you add two negative numbers, the sum is always negative. Is Cheryl's statement true or false? Explain. Well, let's use a number line for this. Okay. So let me do this, and I don't know, red, sure. So here's our number line. I will represent this dash here as 0. Cheryl says when you add two negative numbers, so let's do a -2. So here is a -2. All right. So -2 plus a -4, for example. So then if I start here and go 1, 2, 3, 4 more to the left, because that's what negative means, we're at -3, -4, -5, -6, then my answer is -2 plus a -4 is -6. All right. So when Cheryl says the sum is always negative when you add two negative numbers, Cheryl's statement is definitely true because we're starting at 0 and taking a negative number means to go left, and then adding another negative means to go further left. So you're going further away from 0 on the negative side. So her statement is definitely true. Number 3. Describe the expression 2 plus x represents a number. This number can be located on a number line. When is 2 plus x located to the right of 2? When is it located to the left of 2? Okay, so let me bring in a number line. Okay, so I drew this number line. Here's 0, here's 1, and here is 2. Here's the magic number that we're talking about in this problem. And it says the expression 2 plus x represents a number. So 2 plus x, that means that is some variable. So if x is 0, 2 plus 0 is 2. When x is 1, 2 plus 1 is 3. And when x is, let's say, -1, then 2 plus a -1 or 2 minus 1 is 1. Okay, just to give you an example, when you have a variable like x, that means you can substitute values in for it and find out what that expression is worth or what its value is with that substitution. So when is the term 2 plus x located to the right of 2? In other words, when is it 3 or more? Well, it's when x is positive. Okay. So if x is 1, you get 3. If x was 2, 2 plus 2 is 4. When x is 3, 2 plus 3 is 5. So the number you're plugging into or substituting into x for is the number of spaces you would be to the right of 2. But if I use a 0, 2 plus 0 is equal to 2. It didn't ask that. It says when is it located to the left of 2? And that's when numbers are negative. So this -1 here substituted in for 2, 2 plus a -1, that means 2, and then go left 1 would put me right here at -1 or at +1. 2 plus a -1 is 1, but it's to the left of 2. Now it says, what is the distance between 2 plus x and 2? Well, if x is 0, the distance is 0. If x is 1, the distance is 1. If x is -1, the distance is 1. Okay, so did you hear what I said? When x equals 0, comma, the distance between 2 plus x, 2 plus 0, which is 2, and 2, when x equals 0, the distance between 2 plus x and 2 is this 0. There's no distance. It's at that location because 2 plus 0 is 2. Okay. When x is 1, that would be saying 2 plus 1 equals 3. What is the distance between 2 and 3? Well, it's a distance of 1. All right. So every number greater than 2, the difference between them is the distance between that number. So if I chose 5, 5 plus 2 is 7. The distance between 7 and 2 is that 5 we're plugging in. So what is the distance between 2 plus x and 2? Well, the answer is simply x. Okay. And if it were negative, it would be the same distance because distance can't be negative, right? So if I had, let me do it on the number line for the negative. Okay, so let me erase this. Let's get rid of this dot. Put my line back. So we're at 2. Think of this. What is the distance between 2 plus x and 2? Well, here's 2. Well, if I made x, let's make x equal to -3. So 2 plus x, we'd substitute this in. That would be 2 plus a -3. Okay. And 2 plus a -3, well, that means go over to 2. That's what the 2 means. Start at 0, go to 2. and then turn around and go back 3. And that would put me at -1. Okay. Well, how far is -1 from 2? Well, it's 1, 2, 3. So it is 3 units away. So in other words, it's the absolute value of what you plug in for x. Why is the distance the same when x is positive or negative? Because we're going a distance from 2, either to the right or to the left, but distance is never counted as negative. Okay, next thing, orcas. Orcas are not whales at all. They are actually the largest dolphins. They are social animals that travel in pods or family groups. What benefits do you see from living with multiple generations of your family? Okay, so a little background on orcas. They travel in pods. So number 4 says, an orca is swimming at an elevation of 6 meters. So let me draw a number line. Okay, so I'm going to do a vertical number line. So here is 0. I'll put them over here. An orca swimming at an elevation of -6 meters. Okay, so the orca is right here, starting at -6 meters. So that if I drew a line representing that, it would look like this. Oops. Forgot to grab this tool. Okay. So it's 0 minus 6 will give us -6. Several seconds later, the elevation of the orca increases by 7. So here's 6 and 1 more. Putting us at 1. So -6 plus 7. Okay, so the red is -6. The green is +7. So -6 plus 7 is 1. So it says write an addition expression for the orca's new elevation. Whenever you see the word expression, it means there's no equal sign. So I'm going to write -6 plus 7. Draw a model. I did right here. Part B says describe the orca's new elevation. It is 1 foot above the water surface. Okay, it's sticking its head out of the water a foot, basically. It wouldn't be jumping like that because these things are huge. Okay, so it's sticking its head out 1 foot above the water surface. Okay. All right, closing. Math journal. How is adding 3 plus a -5 similar to adding 3 plus 5? Okay. Well, if we're on a number line, I like these number lines for this stuff. It really makes it clear what's going on with positives and negatives. Okay, so if we have a number line, all right, and let me go back and put my markers in. We always want 0. And that first number is 3, so that's 1, 2, 3. So what I'm going to do is I'm going to use green for the right. So let me get my arrow. Green, one direction, thinner, and here we go. So what that means is you start at 0 and you go to 3. Okay, that's what this 3 means. And then we're going to switch to -5. So that means we start at -3 and go left 3 and then left 2 more. And I need to mark my number line. So here's -1 and we ended up at -2. So taking 3 plus a -5, add 3, subtract 5, or add a -5, How is that similar to adding 3 plus 5? So in the similarity, we went a distance of 3, but then we went a distance of 5 in the opposite direction. That's how that one would end up. But if I did it again using, oops, I don't want double arrow. Cancel. Go back to that and that. And I want green again. So the other way we could do it is adding 3 and 5. Well, here's 0 to 3 is the 3, but then starting at the 3, going to the right, the same distance. 1, 2, 3, 4, 5 would put us at 8. Okay? So this red line and this green line here are both a distance of 5, but one is positive and one is negative, meaning direction, but they have the same length. So how are they similar? We're moving 5 units one direction or the other in our addition portion. And how are they different? One is getting greater, one is getting less. So one's going to the right 5, one is going to the left 5. Okay, so that's the end of lesson 1. Thanks for watching and have a great day.